in this video, I want to give one explanation for why matrix multiplication is defined as it is. Some people explain it in terms of linear transformations, which is one way of thinking about it, but that's a fairly abstract way of thinking about matrix multiplication. Here's one way that I think is more concrete and probably easier to understand. So let's say that you have some variables z1 and z2. And let's say that z1 is the function of y1 and y2, and z2 is a function of y1 and y2. And let's say that they're related by the formula 3y1 plus 2y2 equals z1, and 4y1 minus y2 equals z2. Now let's say that y1 and y2 are themselves functions of x1 and x2. So y1 is a function of x1 and x2, y2 is a function of x1 and x2. So you have these two equations, but let's say that also you have that, say, x1 plus x2 equals y2, and 2x1 plus x2 equals, that should be y1, and 2x1 plus x2 equals y2. Okay, so let's say that you, in addition, know these two equations. So the question is, how do you express z1 in terms of x1 and x2, and how do you express z2 in terms of x1 and x1 and x2? Well, what are you going to do? So these first two equations, z1 is in terms of y1 and y2, right? And the second two equations express y1 and y2 in terms of the x's. So what you can do to get z1 and z2, the z's in terms of the x's, is you can substitute this equation in for y1 here and in for y1 there, and you can substitute the other equation in, so this tells you y2, so you substitute it in for y2 here and y2 there. And that will give you z1 and z2 in terms of x1 and x2. So what do you get when you do that? Well, you get that the first equation is 3 times replacing the y1 by x1 plus x2. And then the y2 is replaced by 2x1 plus x2 equals z1. And then for the second one, it's 4 times x1 plus x2 minus 2x1 plus x2 equals z2. So this expresses z1 and z2 in terms of x1 and x2. And let's simplify that. So this is the same as if you combine the terms 7x1 plus, and then 3 plus 2 is 5x2, and then for z2 it's 2x1 plus 3x2. Okay. Now let's think about what we did in terms of the math, in terms of how we got the 7, the 5, the 2, and the 3. So to get the 7, what we did was so this is a 3 times a 1x1, right? So 3 times 1 and then 2 times 2. So the 7 was 3 times 1 plus 2 times 2. The 5 we got by doing 3 times 1 plus 2 times 1. The 2 in the x1 we got by doing 4x1 minus 2x1. So 4 times, what we did was we did 4 times 1 plus negative 1 times 2. And then the 3 and the 3x2, we got that by doing 4x2 minus x1. So it's 4 times 1 plus negative 1 times 1. So if you think about the computations in terms of the matrices, right? This system of equations, these two equations, basically boils down to 3 times 1 plus 2 times 2 here, 3 times 1 plus 2 times 1 here, 4 times 1 plus negative 1 times 2 here, and then 4 times 1 plus negative 1 times 1 here equals z1, z2. So these numbers are from here, are from the first two equations and then the second two equations. Because the first system of equations I can write as, okay, 3, 2, 4, negative 1, y1, y2 equals z1, z2, and then y1, y2 is this matrix times x1, x2. So substituting what we did here, these last two equations and the first two equations, basically is the same as replacing the y1, y2 here by this. So then you end up getting this. Right? So we saw that this system of equations amounts to what we had above. 3 times 1 plus 2 times 2. 3 times 1 plus 2 times 1. 4 times 1 plus negative 1 times 2. And then 4 times 1 plus negative 1 times 1. And that, okay, so this matrix, if we were to define the product of these two matrices here, we should define this product to be that. So these should be the same. And that's how we define matrix multiplication. So one way to help remember the definition of matrix multiplication is, so if you take, this is your matrix A and that's your matrix B, what you can do is, how does it work? You take your matrix A, you put the rows like this. Here's one way to do it. Okay, so here's A. And then you take your matrix B like this. And then you take dot products to calculate the entries of A, B. So here you get 3 times 1 plus 2 times 2 is 7. Let's use different colors. Okay, so 3 times 1 plus 2 times 2 is 7. And then 3 times 1 plus 2 times 1 is 5. And maybe I'll use a different color. Here. Okay, so 4 times 1 plus negative 1 times 2 is 2. And 4 times 1 plus negative 1 times 1 is 3. So this would be the product AB. So this is a way to explain how you can define matrix multiplication and why it makes sense in terms of systems of equations without referring to linear transformations. Of course, if you think about it, I mean, it's essentially the same thing because you're substituting your y's in terms of x's. So that would be like if you have z in terms of y and y in terms of x, then you're solving for z in terms of x. That's like the composition, right? So in terms of the big picture, it basically is the same as explaining the the composition of linear mappings explanation. But you don't need to talk about linear transformations at all to explain why we define matrix multiplication the way we do. Okay, that's all I wanted to explain in this video. And I wanted to make this video because I've heard math professors say, well, the real reason we multiply matrices like this is because of compositions of linear transformations, which is sort of true, but not really, because you don't need to talk about linear transformations to justify why this is a sensible definition.